For our third problem set, we're looking at a whole lot of polynomial-looking things with a little bit of trig thrown in. Surprisingly, most of these are not U substitution, which seems to be our favorite trick. Instead, they're largely algebra tricks. So for this first one, I'm actually going to do long division of polynomials. I'm going to divide x minus 1 into the polynomial x squared, for which I will put placeholders of 0x and 0 for a constant. Now x times what is x squared gives me an answer of x, then multiply this by the whole thing, I get x squared minus x, which as in all long division I subtract. These cancel, I get x plus 0. X times what is x gives me an answer of 1. 1 times this gives me x minus 1, which I subtract, and we'll get a remainder of 1. So, my integral becomes x plus 1, the quotient, plus remainder of 1 over x minus 1. Okay. And now I can just integrate using power rule and the logarithm rule. So we get an antiderivative of 1/2 x squared plus x plus ln of the absolute value of x minus 1, all plus c. Okay. Technically this is a little U substitution, but since it didn't actually change anything since du is dx, we mostly dispense with actually writing out the U substitution in situations like this. For my second example, I'm going to do something similar, only I'm able to see it quicker, so I am not going to resort to long division. I'm going to rewrite this as x plus 1 over x plus 1 plus 1 over x plus 1, because the 1 plus 1 made the 2. This then becomes the integral of 1 plus 1 over x plus 1, and now I can use my regular rules. Antiderivative becomes x plus ln of the absolute value of x plus 1, all plus c. For my third one, it looks like maybe I should do U substitution with a u equal to 5 plus 4x squared, but you then wouldn't have anything for the du, so I'm not going to do U substitution. Instead, before I try to integrate, I'm going to FOIL out that squared. So I'm going to take 5 plus 4x squared times itself. I get 25 plus 40x squared plus 16x to the 4th. And now it's just a straight up power rule. So this becomes 25x plus 40 over 3x cubed plus 16 over 5x to the 5th, all plus c. Okay. For our final example in this set, we have an honest to goodness U substitution. We're going to let u be the inside portion, which in this case is cosine. So du is minus sine x dx, moving the negative sign over, solving for what I have right here. My integral then becomes 1 over the square root of u times negative du. I'm going to rewrite this as negative u to the minus 1/2 to more easily use power rule. The minus comes along for the ride. The u to the minus 1/2 becomes u to the positive 1/2 divided by 1/2, all plus c, which in reality is minus 2 times the square root of u, or the square root of cosine x, all plus c. Okay. So don't forget the algebra tricks as well as the standard calculus tricks.